Welcome. Well, we've seen a lot of spacecraft today and yesterday, people going up in space. I'll promise you I'm going to take it even higher up, right, into the infinite space called 64-bit. So don't be afraid. It's going to be all right. If you feel the need to jump, please don't. It's not safe. But yeah, if you feel this is all going ahead, please feel free to leave. Because of course it's going to be quite technical today, just like the Professor Kumar. So I promise you that. Okay, let's first do the introductions. Let's first talk about you guys. Have you all built VBA macros in the past? And I mean big ones, right? Not one-liners, no, large ones. And have you maintained them for years and they've grown and they've got bigger and bigger and bigger? If that applies to you, then okay, good. But have you even built them using DLLs of any sort, like Windows DLLs or ActiveX controls? No? Yeah, I see some hands there. And are you now using SolidWorks 2013 64-bit? Right? Yeah? Okay. Good. Now you've come to the right place and the right time with us. That's what we are going to talk about today in detail. The talk itself, 64-bit sounds a bit foreboding, so I'm going to gently introduce you into the topic of 64-bit. And you think, why is he doing that? Well, it will come back later. So we have to build the base first to understand the bits that come at the end. I'm also going to talk a bit about the history of Visual Basic for applications to see where it came from, where we are today, where it's headed. And then I'll introduce you to SolidWorks 2013, where we have started using VBA 7 and introduced the 64-bit that comes with it now. And this is what it's all about, the last bit, is that you have created these macros over time, they've grown, and now you want to keep using them on a 64-bit platform. Is the volume not high enough? Sorry. Is this better? Yeah? Okay, it's just the buttons probably. Okay, sorry. So we want to keep your macros going for as long as possible, and you may have already found out that it's not something that comes automatic if you start using all these DLLs. So that's what we're going to talk about. Keep your macros going as they are, using ActiveX controls, Windows DLLs, and COM libraries. That's the other one we're going to talk about today. Yeah, so it's all about all that investment that you make over time, all those blood, sweat, and tears that is common in programming to make that work. Keep it working. A few words about myself. My name is Frank Lindemann. I've been with SolidWorks since 2004. I've always been a member of the API group. Actually, there are two other members here in white, the two gentlemen here. I've been doing API support, working with customers, partners, everyone who uses the API. I've worked in the OEM team, which is a very special version of SolidWorks which some of our partners use to build products of their own and sell them under their own name. And these days I look after partners in general. So all the partners, if they need help for some time, for complicated issues, I will hold their hand. I am based in Cambridge in the UK, but I originally hail from Holland. So the linking pin here is the water. Wherever there's water, I'm happy. Okay. Let's see if this works. So we've done the introductions. This is what we're going to talk about today. The change from 32-bit to 64-bit. So we're going to pretend, first we're going to go back in time. Let's pretend there were only 32-bit computers. How were things back then? And what's the current situation? What has changed? And actually there was a period in between where we were all a bit in limbo. We're going to talk about that as well. Then we'll briefly go over Visual Basic as we know it today. And then finally I'm introducing the 64-bit Visual Basic 7. What's new in the language, what has changed, what has been added. And then I'll run a few case studies with you showing how macros can be changed or have to be changed to keep them going. And they're all based on real customer issues. So this is not something we're making up just for the fun. These are all customers have come to us, okay, my macro stopped working, Frank. What can we do about it? And then we take our bag of tricks and we revive them and keep them going. So, depending on the time we have, I'll pick and choose. I have 4 case studies prepared. I'll pick a few. Some are probably self-explanatory. You get the stuff later on after the meeting. The other ones probably need to be a bit more explanation and pictures. Okay, then there will be time for questions. And I've thrown in a set of slides for references, so you can look things up on the web. And there will be some extras which I just put together, preparing for the presentations, which I'd also like to share with you, but not today, but you can take that home. So lots of background stuff on Visual Basic. Okay, so I'm going to dazzle you with some bits and bytes and travel through space. Yep, we're going to talk about the lowest possible level of 64-bit. What is a bit? I don't know if you're programmers, but this is what it's all about. It's about those on and off flags. 1 bit can have 2 values, 1, 0. That's what computers are all about. Now, that's not very handy, so we take them together. The smallest possible unit that we can actually address in computer memory is called a byte. Right? It's made of 8 bits, 8 on and off flags, which can take various values. And we can attach an address to a byte. And in programming terminology, we call it a pointer. So it points to the byte somewhere in the memory of your computer. So terms you have to remember because they will keep coming back. Yeah. So graphically, this is what it looks like. We have your storage, your computer memory, and somewhere up there lives a byte. And we can point to it and we know where it lives. This is not new. We all have other examples of address schemes, like your postal address. It's a very common one. Seat numbers, theaters or on an aircraft. And one that's very important to remember if you come back to after SolidWorks World, where did you leave your car at the airport in the long-term parking, right? Do you all have your ticket, your number? Did you write it down? Yes? No? Okay. Okay. Now, what can you actually store in these bytes? It's just a set of zeros and ones, but what do they actually mean? And actually, what they mean depends on what you want it to be, right? So it can be a number 83, and the same set of bits can mean the character S for SolidWorks, or it can be an instruction for your CPU to add one register to the other and do some magic with it. So it depends on, it's context dependent. Those bytes can mean anything. So that fits in 1 byte. How many do we have? We say we can address. We have 4 bytes available. There's the word byte again. So that means we can actually address 4 gigabytes. Right? So that's where the name comes from. The 32-bit world, we need 4 bytes, which makes up 32 bits. And it's actually the size of an address. Of course, that's not the entire story. It's also the width of your CPU registers, just to make sure that all those 32-bit data can be fed into the CPU, being processed, and then data can be spit out again. So, okay, I hope so far nothing new. Actually, and this will also come back later, we can do arithmetic with pointers, with addresses. We can actually think about what's the next byte in memory, or what's the previous one. So we can do math with it, or what's the one before that. So always good to know you can actually do this, do some calculation with it. There's also a very special value that we keep around. It's all zeros, and it actually means address unknown. Basically say, we don't know where this byte lives, we don't have a byte, we have nothing. So lots of question marks. Yeah. So you have to treat that with care and respect. If you try to use this byte and your computer will basically say, can't do it, I will crash. Yeah. Okay. So before we saw we can use a byte to represent certain data types, but what if we need more than that? Say, what if we need more characters for the entire word SolidWorks? How much data do we need? So we need more than 1 byte. That's what you call a string. But if those bytes can also represent a floating point number or a very large integer, something that doesn't fit into 1 byte, but it's still an integer. You can just do 1, 2, 3, 4, 5, etc. But it doesn't fit into 32 bits. The other thing it could be even more complicated than that. Could be a complete address, a postal address. So it needs more strings, more numbers together. They make up what we call a complex data structure. Or, and there it is again, a pointer, which we've just said is 4 bytes, needs 4 bytes. So it's also needs space. And we all call these guys data. And the other type of bytes that pointers can point to is code. As you've seen, it can be an instruction, which can be 1 byte long. And in the Windows Intel world, some instructions can actually be more than 1 byte long. So we call that CSIC, processes, complex instruction set. Complex instruction set. C, I forgot what the C stands for, sorry. But, and this is where we come back to this later in Visual Basic, it could also mean the start address where your macro code lives, or a function in your macro. And we can pass that around, as we will see. So let's see what that looks like. So on the left-hand side, we have your 4 gigabytes of storage, addresses ranging from 0 to FFF, that's all ones, but in hexagonal notation. We have a 32-bit pointer pointing to your 1 byte. But as I've said, your pointer needs space as well, so we collapse it on the right-hand side. So we need 4 bytes to store a pointer to 1 byte. Now, that's not very economic, actually. So, but that's how it is. Okay. So here is an example of what a pointer can point to. It's a string SolidWorks. So we can see here. This is my. I hope you can see the laser pointer. There is the 4 bytes for the address. It points to the S. But after the S, there will be other bytes spelling out the word SolidWorks. And the one at the end is a special one. It's called a null character. Saying, okay, this is the end of it. This is. We'll also come back later. You will see sometimes we add nulls to strings if we start to work with Windows APIs. Windows, in general, strings are ended up by null characters. The picture on the far right, actually, a pointer can point to another pointer, which is pointing to 1 byte of data in memory. So, some of the examples will actually use this concept, like a pointer can point to another pointer, and from there you get to the actual data. So it's like an indirect reference. Okay. As I said, pointers can also point to code. Here is the simplest macro in SolidWorks you can think of. It's like the hello world of VBA in SolidWorks. But those lines of code, your VBA code has to live somewhere in memory. And we can take the address and say, okay, this address, there lives a function, and we can pass that around and execute it. Or let other people execute it for us. Okay. So, moving on. As we all know, 4 gigabytes wasn't enough. We need more of it. The problem is we had to keep the byte as the smallest unit which we can attach an address to. So the only solution left for us is to use more bytes, which means we need more addresses. So we have to use more space for address. We have to widen the address. So it's extended to 8 bytes. I can't tell you how much that is, but it's for 16 exabytes. That's quite a lot. It's an enormous amount of bytes. But this explains the name. We use 8 bytes, and it makes up 64 bits, and that's where the name comes from. So, of course, your CPU also has to now have registers 64 bits wide to make sure the data can be pushed into it and moved back to memory. Yeah. So, graphically, and this is certainly not to scale, on the left-hand side, the 32-bit address space, and it fits somewhere in the bottom of the 64-bit address space, but it's not to scale. But as you can see, we now need 8 bytes to represent an address, so we need to actually when we're working with data, we have to shove 4 more bytes around. So we need to push more data around, but that means that 64-bit is not necessarily faster, because you continuously have to shove more data around. Of course, no one will ever notice with the processor speeds these days, but if you get fuzzy, then you have to push more data around. Okay. So, coming back to Mr. Baumgartner on Monday, this is where his limits are, right? This is the Armstrong limit. And we're going beyond that with 64-bit. We're going to venture into 64-bit space. Okay. This whole address widening thing is not uncommon. It's happened to telephone numbers over time, probably many times. Like in the olden days, you had probably 4 digits. You want to call into the next village. These days, if I want to call someone in HQ in Waltham, I need a lot of numbers. So, and probably one day we'll run out of digits again, and we'll have to extend the address or the telephone number scheme again, right? And you will probably see it in zip codes as well at some point. And another example, closer to home, closer to programming or IT in general, is we were right in the middle of one, an important one. We're going from IP version 4 to IP version 6, which was also based on 32 bits. We ran out of addresses for that. Everyone has a cell phone, everyone has an IP address on his cell phone, or even multiple if you have Bluetooth, etc. So that address is also being widened to 128 bits. So a very large number. Lots of addresses, and hopefully we won't run out in the next, God knows how many years. We'll probably not live to see it. But. Okay, so that sets the scene in terms of what 64-bit is. Now I'm going to move on to Visual Basic. As you can see from this icon or this image, it's pretty dated, right? It has been around for a while. This is one of the best graphics I could find. It's not very slick, is it? This goes back a long way. So what does it do? Where does it came from? It's derived from Visual Basic, obviously. It's actually completely compatible with Visual Basic, language-wise. Whereas Visual Basic allows you to build your own executables, your own applications, or DLLs for that. Visual Basic requires a host. It's not a parasite, but it does require a host. And the best thing you can do then with your host is to automate tasks in it, or customize it. But the host has always to be alive. Did I see a hand? No, oh sorry, that's what you were waving. Okay, looking at the picture, it has been around for a while, version 6 since 1998. Now, in programming terms, in programming land, in IT, well, that's a dinosaur, right? We thought this was extinct. Well, it's pretty much there, it's still alive, but yeah, it's been going strong. And many people wonder why, but I think Microsoft just hit the right spot. It's not too complicated. It's still very powerful, and everyone loves it, right? You can still perform lots of good things with Visual Basic without going to C or C++ or any other stuff. So in time, this is what we've seen. I have never used Visual Basic 5. I've only started working with Visual Basic when it was version 6. And Visual Basic for application 6 derives from that, so it's almost identical, except for the host application. But then just to put things in perspective, at this point in time, there was a break, and Microsoft continued with all the .NET technology. So starting in 2002, and slowly moving forward. At some point, we introduced VSTA, which is Visual Tools for Applications, the other macro programming language in SolidWorks, but then for VB.NET and C#. So that's a spin-off that came in existence in 2005, and now we're moving towards Visual Basic 2008, and currently we're here, right, 2010. We're not going to talk about that today, but this is just to put things in perspective. Okay. Well, you all know it has all sorts of familiar programming constructs. It is procedural. It means it has functions you can call. It actually has object orientation. So you have an object in your hand and you call methods on the object, which at the end of the day are functions, but it makes it more logical to work with an object like a form or a button or an address. The other concept that's familiar to you is it's event-driven. Visual Basic can fire off events. You can respond to that in your event handler. So all common stuff you find all over in all sorts of programming language. VB has it. It comes with an integrated development environment, which is baked into SolidWorks. That comes with a graphical form editor, so you can just drag and drop buttons on it, position them, and you're in business. So it's actually quite quick. It's technically it's a combination of interpreted language and compilation, so there's actually a compiler working in the background for you, but you hardly notice it. It will spit out machine code. So it's actually quite quick. It runs very good. So that all makes it ideal for quick tests and proof of concepts. And actually, I'm surprised how much VBA code I write on a daily basis just to explain some SolidWorks APIs to someone. Just say, okay, you type it in, and then you say, okay, this is how it works. And now you go figure and translate it to C# or C++, which will take weeks. But okay, my job's done by then. So it's very good. And also to communicate bugs to developers, you just write up a quick macro, say, okay, guys, this is crashing. So it's 2 lines of code, and they can fix the bug for you. So yeah, it's brilliant. What you don't know probably is it's based on Microsoft's component object model. And the reason you don't know is they try to hide it. So you work with objects and methods, but under the hood it will create COM objects. But yeah, they don't want you to know about it, which is probably why it's so powerful, because you don't have to worry about it. Because COM is quite complicated, and yeah, if you need to go into the innards of COM, it's a pain in C++. But it's all well hidden, and it's good. The other thing it hides for you completely is pointer magic, as I call it. Yeah, you can do very powerful, very fancy things with pointer, just poking around in memory. But Visual Basic hides it for you, which is of course not entirely true. We come back to that in a few slides, because as soon as you start to use Windows DLLs, you'll be facing pointers, because that's what the Win32 API is all about, pointers. But for now, let's assume it's all well hidden. Okay. It works very well with SolidWorks VBA, because our API is also COM-based, so it's a natural match. It's completely transparent, so it works very well. It's built in because, yeah, of course, it needs a host application. And the good thing about it, you can debug your macros while SolidWorks is, you can still use SolidWorks. It doesn't lock up. You can just click around, select things, and then immediately see the selection in your macro, stop your macro, do some more selections, and see the selections change. Oh, it is actually fantastic. And it's still very hard to do things like that in the C++ world these days. It's called edit and continue, but usually it doesn't mean you can't do anything. VBA has always had it since 1998. And surprisingly, it's fast. It all runs in the SolidWorks process. COM is actually stepping out of the loop. I'll show some graphics about that later. It's actually not even there. You think, well, it's in the same address space. I'm not needed. I step out, which means your macro is called straight into our SolidWorks C++ code, and it's blindingly fast. So, which is good. And the other good thing is, of course, you can use this in any other Office application. So you can just copy and paste code around. And yeah, people do the craziest things, like as I say here, you can run VBA in an Excel design table embedded in SolidWorks. People do that, right? If the functions in Excel are not sufficient, you write your own macro code, and there is your BOM or your design table. So this is a UK joke. We have Marmite, right, which is a yeast spread, and their own advertising slogan is either you hate it or you love it. And I think it's the same with Visual Basic. Either you hate it, being a C++ programmer, or you love it. You can do magic with it. So, okay. So how it's being used? Well, actually, the list is quite small. It's only, we use macros, and our equations are Visual Basic based. So, and that's actually it. But that's more than enough. And what do you guys do with it? And I think this list is endless. I'm always surprised what people do with Visual Basic, how complex the applications can be sometimes, the macros like. These are a few examples. People enforce company standards, so all the designers in the design office use the same templates, don't touch certain options, or, well, just to make sure everyone's on the same playing field. Or complete product configurators, very similar standard part generators, complex commands with their own property manager pages, macro features, you can do that. You can even embed the macro into the SolidWorks document, so the macro feature always travels with the document. People build, like I call mini PDM systems, check in, check out, different steps in the workflow, so you don't even need EPDM, I would say. But you can all do it. People do document checking, we do cleanup. That's actually what we also do in the API team quite a lot. There's a broken feature somewhere, and the customer has 10,000 documents, and our tech support comes to us, well, can you clean it up with a macro? And run all 10,000 files and batch through them. The same thing for corrupt documents where there's a cache and the document got corrupted. Can we fix it? Can we repair it? And we do some magic with the SolidWorks API and stick it in a macro, and then hopefully the documents can be used again. And you'll probably have other examples what you guys do with it, and it's amazing sometimes. Okay, but that's not the end of the story. We can do more, as you probably all know, and that's why you're here probably, because you've done this. You can use dynamic link libraries in combination with Visual Basic. So it's actually just a library of callable functions at a very low level, and multiple applications share those libraries. So there's an economy of scale here because you only write the DLL once and all your applications can use it, so that's quite efficient. And you can use that with VBA. And it comes with built-in support to use the native ones, native DLLs, so the ones that Windows supplies to you, like use 32, shell 32, or you can actually write your own if you want to. Or you have some contractor who writes something in C++ for you, and you can use that from Visual Basic. The other important flavor of DLLs is ActiveX controls. This is one. The most useful ones are usually the Microsoft Common controls. They're just very complicated COM objects, what we call ActiveX controls. One level below that is just what we call in-process COM server DLLs, and a familiar one is our Document Manager API. That's a DLL with a set of COM objects. You can just reference that in your macro in your own business. Another one, which I'm going to talk about today as well, and one of the use cases is the ADO, the ActiveX data objects, which is also an in-process COM server. Okay, let's quickly go through what do you need to do to use these DLLs, because this is where the problem will be later. We have to change the way we use these DLLs. So I'm going to run through it like it is now, like ideal world, and then we'll see the changes in Visual Basic, and then we see how we can adapt our code to that. So let's first look at the native DLLs, how you use them, the declare standard, the declare statement. Has anyone used that in the past? Yeah, 2 hands, 1, 2, 3, 4. Okay, not so many then. But okay, this is what it looks like. This is the syntax for it. And basically all it says is you tell VBA what the function looks like. Yeah, so it's basically you telling the compiler, and the compiler is not going to help you. So it assumes you've done a great job. It will compile properly, but it doesn't mean you've done it correctly. Yeah, you haven't specified the arguments correctly or the return type or stuff like that. So something to bear in mind. You tell the compiler what to do, and it doesn't help you. Okay. So where do you go to find these functions you want to use? Well, the biggest source of information, of course, is the Microsoft Development Network. All this stuff, all their functions are online. If you don't want to go online, or you have the Microsoft SDK, all the include files will be on your disk, and they're also a great source of information. Just to find out what the functions are, what their arguments are, and the presentation will contain links later on, so you don't have to write all these down. And of course, Google is your friend, or Bing is your friend. Just search for them. You're not alone in this world. There's so many other programmers who've looked at this before, have found a useful function, documented it somewhere. The entire site's dedicated to doing this. So search engines are your friend here. And you need it. You need Mr. Sherlock Holmes at some point. Because what happens is that sometimes the arguments is of a certain type and is defined in terms of other types. So it becomes like a complex data structure. And we'll see some examples. So you have to actually go from one step to the next to say, okay, have I figured it out correctly for all the types I'm using? So it quickly escalates sometimes. Like you use one function, it has one argument, but it's made of a complex data type. It uses yet another, which is quite common in the Windows API. There's sometimes no end to it. So you end up with 6 or 10 different data types just to call the one function. And you have to populate all that data first to use them. So yeah, there was a bit of sleuthing involved here. The problem you will find is that some people translate things differently. So they know about C or C++, they think, okay, I know this data type, it must be a long in VBA. And the other guys think, no, I make it a bool or a short or a double. And it all works. And so again, it's an example. When you tell in the compiler, and different people tell the compiler differently, and it all works. So let's just pick one. And this comes back in one of the examples. Just given a pointer, actually that's what it says. It uses the word address. This means it's a pointer. Give me back a path name. And this can be the My Documents path, or your favorites path, or another path on the system. So a pointer comes in and a string comes out. And if it succeeds, it will return a Boolean value saying, okay, I've done, it worked. Yeah. Where does this function live? You can find this on MSDN. It lives in shell 32. And if you can read it, I've used the dependency walker tool here. That gives me the contents of shell 32. And there is the function. Right. So, there are actually 3 of them. I'll come back to that later, perhaps. There is, in the extra slides, I go into this, because you'll see there are different flavors of strings in the Windows world. For now, let's just press on, ignore that. But yeah, if you want everyone to use this tool, it will tell you what other DLLs one DLL depends on. Quite a few, actually. But this is where I'll find that function. So, as Mr. Holmes said, these are pointers, but we have no problem with that. We can use a 32-bit long integer just to store that. It's a number for now. Let's store it in there. So with that in hand, we can come up with 2 different definitions of this Windows function, and I make them differ in the return type. All perfectly valid, because I know a bool in the Windows world is 2 bytes. So it doesn't really matter. I can just stick that in 4 bytes on my end, or in a Boolean, which is also 2 bytes on my end. It will all work, right? So this is why you probably see different definitions for different functions on the web or in documentation. So always good to cross-check, because sometimes things go wrong. They use the wrong type, and it doesn't bother them for a long time, and so in your case, it may be a problem. So always good to do a cross-reference on how people have translated the Microsoft function into a declare statement. Okay, that's basically all there is to it. So once you've got that right, your macro is up and running. So let's move on to the next type of DLL we're going to use, is the ActiveX control. This was Microsoft's technology to make very standalone visual components, which you can just drop into your application. It doesn't really matter which language it was written in, as long as it supports COM and the ActiveX protocol. You can use that control in your application. It has, as I say at the bottom, it's a very complicated object to do all that, because one of the things it has to support, if you're working your Visual Basic editor, and you want to configure that control, the control has to support that. So that's why it's quite a complicated thing to do, to make one. But once that's been done, it's very easy to use, and you can just drag and drop them onto your form, and you're in business. Simple examples are the sliders, and the common controls, the calendars, grid, trees, the common file dialogues, the open files, print dialogues, etc. Or a complete web browser, which you can use to show web pages inside in your Visual Basic application. But although it's very complex, at the end of the day, it's a DLL. It may have been called a .ocx file, but it's a DLL. So just bear that in mind. It's all in the name. You've all seen this, right here. So you go into your Visual Basic editor, you bring up your toolbox, you say, give me some additional controls, and there are 2. So I've used the tree here and the associated image list, but yeah, it's quite, you tick the box, it will appear, you drag and drop it, configure it, and off you go. Behind the scenes, Visual Basic will add it to the tools, references, and that will bring up this. So it will tell you, okay, you've referenced this library here, which is this DLL. So it all does that for you. And if you would click on, say, the tree here, there will be a custom property button here, and you can configure the tree, or you can do it in code. Let's say populate it with data, which I've done here in this example, comes with the presentation. But here I just go through all the components using the SolidWorks API, building up a tree, sticking in a nice icon, and there you are. So, okay, coming down one level, it's coming to COM server DLLs, which are usually simpler COM objects because they don't have this vision, they don't need this visual aspect, they don't have these properties that are needed at design time. They don't have to hook into the entire Windows structure to show themselves in any environment, whether it's VBA or C++ or even .NET. So they're quite simple, relatively speaking. The examples I've mentioned earlier are Document Manager API or the ActiveX data object. So I hope you can all read this. Yeah, this time you have to add the reference yourself to the DLL, and from there on you just use it like the SolidWorks API. You know the name of the library, the name of the object you want to use, and then you call methods on them, and again, you're in business. Yeah. Okay, so far so good. As I said, we made a step back in time. We all imagined there were just 32-bit computers and Visual Basic 6 worked like a charm. But then the problem started. Of course, these 64-bit computers were invented. We jumped on that. We support 64-bit going back as far as SolidWorks 2006 on Windows XP. The problem we had was that it doesn't exist there was no native support from the VBA side. That took Microsoft until version 2010 of Office to introduce that. That has been around for a couple of years now, and they basically we were not able to get hold of the SDK. So we couldn't just copy and paste the code, or recompile it on our end and be done with it. No, we had to do something special. So we need, until 2013, we had to live with this intermediate solution, which I'm going to explain. And it will come back later, because it will be one of the tricks we also have to use to keep your macros running. So it will come back. But what does our intermediate solution look like? We had to introduce a separate host application. So what we did, we invented a new host application called SWVBA server, which was 32-bit, and that was able to just accommodate to host Visual Basic 6. That is our trick. And then next to that, we had SolidWorks 64-bit, and as I said, this was all Visual Basic, it's all COM-based, so we have COM sitting in the middle here, going from one process to the other or back. So with this trick, it all worked nicely. In the COM terminology, it's called location independence. The objects, the COM objects, don't really, or the users of the COM objects don't really care where the object lives. So we showed it here. So we have again the basic SolidWorks Hello World. We can use that in both worlds now, as is. So whenever you call something on, say, SW app, we don't really care where the object actually does its work. So if we call it from Visual Basic 6 living in this separate process, we don't actually care that actually the work is being done in SolidWorks and it gives us back to the results. It's all transparent, thanks to COM. Right, that's something. COM has always been designed to do that, so we've taken advantage of that. So it's all transparent. You don't really care. So as I said before, in the old world, in the 32-bit world, it works the same. It's all COM-based, but actually COM will step back, saying nothing to do for me here. It's all in the same process, so I step out of the loop, and that's why it's so fast. So although we are location independent, it will come at a cost, of course, as you can imagine. The good thing about this setup is that all the DLLs you had been using all those years, you can continue to use, because that DLL must have been 32-bit in SolidWorks 32-bit, but since our new host application, the replacement or the alternative is also 32 bits, you can continue to use those DLLs. So everything was fine, everything was peachy, no problems. Yeah, we could press ahead, no worries. Of course, we on the SolidWorks side were not entirely happy with this solution, because if you've seen, you make a call in Visual Basic and it has to go across the process boundary to SolidWorks, do the work, come back. That will take time. So it's always a bit slower. If you do a lot of these calls, you will notice. It depends on your application whether you will notice, but okay, it will happen. The other thing we always saw is it's always hard to have two different applications which have to work together, and at startup time they have to basically meet up, and sometimes that would go wrong. If the startup of the Visual Basic host process was held up a few microseconds, SolidWorks will be further in the digitalization or the other way around, so we didn't really like it. And of course we had more code to maintain. And this was always a good example why things were not ideal on the user side, is your form started to pop up behind SolidWorks. The reason was simple, because the form was now owned by that surrogate host process, the Visual Basic server. It didn't know it was actually part of SolidWorks, so it would pop up anywhere on the screen, usually behind SolidWorks. So we had to write this solution saying, okay, we have to use some Windows 32 APIs to make sure that the Windows knows its correct place. It's owned by SolidWorks. So we have to do some magic, saying you're now part of the SolidWorks window hierarchy and not of the VBA one. Okay. So yeah, it was not ideal. But thank goodness, in 2013, the wait is over. Visual Basic is here, Visual Basic 7. All our problems will be solved. So putting this in perspective, again, Visual Basic for application 7 derives from Visual Basic 6. It's a thicker arrow this time, meaning trouble ahead. There will be changes. It's not peachy. But just make sure that this 7 here, this version 7, has nothing to do with this version 7. So they could have called it 6.1 or something. Now they called it 7, but it has nothing to do with version 7 here on .NET. We had someone being very worried that all the changes you have to make to your Visual Basic code to make it VB.NET code, they can be quite substantial because the language changed dramatically. That's not needed here. These languages are still very, very compatible. Right? There's no worry here. Okay. So it's 100% compatible. So anything you've written in 2012 or earlier will just run in 2013, and also the other way around. Anything you type into 2013 can run in 2012 or earlier. Of course, the good thing is it now supports 64-bit. We can just embed it in SolidWorks 64-bit or SolidWorks 32-bit without having to change any code. So that's good. And on top of that, it comes with some built-in data types which are 64 bits wide, which makes working with 64 data easier. So let's have a look at that. So everything is looks fine over here. The same macro will run again in each application. In both cases, COM will step out of the loop, so your Visual Basic application in the 64-byte will be as fast as ever. This solution no longer applies because now the VBA forms you create are owned by SolidWorks, so it will pop up in the right place. Yeah, it knows its parent correctly, so we can just forget about this solution. Okay, what is new in the language itself? VBA 6 always had these 3 integer types. One of them unsigned, the 8-bit one, and 2 signed ones, which means you can use negative numbers. That has always been there. And there's a small tip at the bottom. There's a very large table in the API help explaining the differences between the long and integers in all the languages we support. And I can tell you it's quite confusing. They all use either capital or lowercase longs and integers. There are long longs, long int32 in VB.NET. So we've put together a table which explains all these data types in the various languages, just to make sure you do use the right one in each of the languages. And when VBA7 came around, we had to adopt and change the table and add the long type, which is new in VBA7. It's 64 bits wide, it's signed, it's an integer number, very similar to what you've seen before. And in case you're using a hardwired number, a constant, just make sure you postfix it with a just otherwise the Visual Basic IDE, the editor, will just truncate it at some point and say, oh, this is a double. I turn it into a double. And then it's, and you end up with the wrong number. Just a tip. So if you call type name on it, it will return the value long. And if you stick it into a variant, it will come back with a VB long or a VTI8, which how we call it in the C++ world. So far, so good, but there is a catch. It's only available when you're running in 64-bit SolidWorks. So in 32-bit SolidWorks, even though it's VBA7, this long doesn't exist. It says can't do it, which is weird. If we've seen, we go back to the earlier slides. If we can point to data types of any length, basically. Whether it's 2, 4, or 6, or 100 bytes long. Why couldn't they make this work for this data type here on 32-bit? So there's trouble ahead, as you can see. The other good thing is that now you no longer need to use an integer to store pointers if you need them for the Windows API. No, there is a native type called long PTR, which is of course an abbreviation for pointer. It's built in, and it can do magic. Depending on where you run it, it will change its size silently, just to make it easy for you. So in the 32-bit, it will be 4 bytes wide. In the 64-bit world, it will be automatically 8 bytes wide. So it adapts to its environment. That's brilliant. But again, there is trouble ahead, right? That's why it's involved. Of course, the type name is long or long, depending on where you call it. And this special value I mentioned earlier, the null value, is just a 0 with a hat behind it. Just in case you need to check, do I actually have a pointer here? Is this just address unknown? And I can't do anything with this number. Okay. So, until now it was plain sailing. I want you all to stay calm. Yeah, there's no need to worry. Of course, it's getting worse from here, but we'll recover from that. The problem now is you always use this 32-bit DLL, but Windows doesn't allow you to use that in the 64-bit process. It simply says, can't do it, I don't want it. All the DLLs in the 64-bit application have to be compiled for 64-bit specifically. Because all these addresses and data types, it has to know about it in terms of 64-bit addresses. So there is no way about it. You can't use your DLL anymore. You need another copy of it alongside your 32-bit copy. Or if you don't worry about 32-bit SolidWorks anymore, just need to get hold of that 64-bit copy of that DLL. Right, so if you don't have one, Visual Basic will complain loudly. In the case of a native DLL, as soon as you start to run your application, it will say file not found. Yeah, I made up the name non-existing DLL, but it will tell you. Yeah, and the problem is it only will tell you at runtime. So you load your macro, thinks everything is fine, you start to run it, and it will tell you, I can't find this DLL on 64-bit. So, problem. ActiveX controls. If you go and load your macro up in SolidWorks 2013, it will tell you as soon as you load it. It says, some of your objects I can't find on this machine. Your sliders, don't know where they are. Your buttons or your special grids, I don't know where they are. And if you then open up tools references, it will say missing. Can't find. At design time, if you look at your form, it will be empty will be staring at you, empty spaces. It will not appear on your toolbox. So, and as soon as you run it, if you haven't, it hasn't sunk in then so again, it can't find the object. So, okay. The same thing for in-process COM DLLs. It will tell you in different ways. It can't find it in the references, or it says, well, SLDWorks or Doc Manager. What's that? Don't know what that is. So it will complain loudly. If you look at your references, you will see the word missing all over the place. Okay, so at least it will tell you. But how do we go from there? How do we find a 64-bit copy of your DLL? Again, Sherlock Holmes from the UK is coming to our rescue. The simplest thing, of course, is to contact your vendor, dial them up and say, do you have a 64-bit copy for me? That's the easiest way. In many cases, it will probably just already be sitting on your disk without knowing it, but it's just a matter of finding it. If you have the luxury of having the source code of it, you just recompile it. If you have a 64-bit compiler, Visual Studio, just press the button, recompile for the 64-bit configuration, and it should be okay. Or you have to go find an alternative. If you can't find anything, just go look elsewhere. I'll have some examples of that. In the case of ActiveX controls, again, you have to contact the vendor if they've gone through the trouble of porting it, or again, compile from source. Here are more variations. If the source is available to you in a .NET language, and .NET, as we all know, compiles to the Microsoft Intermediate language, which is platform independent, the best thing to do is to say, okay, compile it for any CPU. Keep it independent of the CPU, and then at runtime, the .NET framework will figure out what machine you're running on. But if you have that available to you, just change it to any CPU, and you should be fine. If there are dependencies on native DLLs, you're back to square one. Because then again, you need a 64-bit version of that DLL. So there is a catch here. Okay. Another solution would be to not use the ActiveX control, but actually use the Win32 APIs it uses under the hood. There's an example here. Many of these controls, these ActiveX controls, are just wrappers around existing Win32 APIs. The file, get a file name or get a folder name. They're just wrappers, just to make these functions available in other environments. Like JavaScript can't take a native DLL, but it can take an ActiveX control, so it can use that wrapper. So you basically have to go down one level and use it from there. The other one is, of course, find something else, either free or commercial replacement. It can be a bit of a search to find what you're looking for. If it has the exact properties you've been using, whether it takes your images, etc. Or if you're up to it and you have a spare weekend, just write your own, which is not probably done in a weekend, but okay. But it can be done. But it's the same thing for the in-process COM servers, just contact the vendor. So in our case, for Document Manager, you're done, because we, of course, provide a 64-bit version of that. So it should be okay if you have the source recompile. Or we're going to use a trick, and this is one of the use cases I have. You can actually reuse your 32-bit DLL in another process called the COM surrogate host. That's a mouthful, so I'll have more pictures of that later to see how that could work. But you are on your own in this respect, because the developers who wrote your DLL may not have prepared it correctly for this use. So it's, you have to try it. And we're going to try that later. If you look up this support statement, you will actually see that Visual Basic 6 and its runtime will continue to be supported on Windows 8, so that's good news. But if you read through it and let it sink in, you'll figure out that for the common controls, the sliders, the dialogues, etc., you were used to use, there is no 64-bit replacement. So that is really bad news, because this is used by many people. So again, you have to find an alternative or write your own, as I said, using Win32 APIs. But this is very frustrating because these controls have been in existence so long, and yeah, they could have ported it, but we have to live with it. We'll find some ways around it. So, what else is new? Question.
You're saying all ActiveX controls?
No, just the ones that are known under the name Microsoft Common Controls. So, which are the grids and the trees. The one that I've shown one, that's no longer there. So you have to go find out case by case whether there is an equivalent for it, or you have to go somewhere else. Okay. What else is new in the language? If you now want to use a native DLL with functions in it, the language will actually ask from you, say, it have to have this PTR safe keyword in it. It's like you have to add it. Without it, it won't compile. It's a bit. Actually, as I say here, it requires you to add it, but it doesn't add any value. It's still you telling the compiler, this is what the function looks like, and then you say, okay, I'll add the PTR safe, but actually still, it can be wrong. So there is actually no guarantee whatsoever that the declare statement is correct. But yeah, it's mandatory on 64-bit, even if you don't use pointers. And so it just wants to see it on every function and method that you use from a DLL. So that's a bit, can be quite tedious. Luckily, it's ignored on 32-bit. On 32-bit, it doesn't. If it's there, it's fine. If it's not there, it's also fine. But if you want to go back to Visual Basic 6, it doesn't know about it, which is, of course, obvious because it goes back to 1998. And so, again, there is trouble ahead. So what do you need to do here? You basically have to go through all the documentation and check each and every declare statement you have to see if it needs to be changed for 64-bit. And as I said, you always have to cross-check with other sources. Other people may have done it before you and may have come back with different results, and you have to figure out which one is the best one. Unfortunately, there is no silver bullet here. We don't have a nice converter, so do it for you. But there's also a bit of good news. On the web, Microsoft has documented all the changes they made for 64-bit. They listed them per release, and even better, I was trying to show that. You can just download a file which will give you each and every Microsoft function. So the one we're looking at right now is the one for 32-bit. Let's have a look at this get current process function. Sorry? Ooh, sorry. Change the text size. Can I zoom in for now? Better? Slightly better? Slightly better? Okay, but I was going to look at this guy here. So the return value here is long. And if you download the 64-bit equivalent of this file, you'll see that this is a long pointer now. So this is good to have. Every function in the Windows 32 API is here. So that's good. One thing to bear in mind that when Windows itself was migrated to 64-bit, Microsoft had to go in and change some of these functions because they were not correctly set up for the port. So if you look at the set window long method, at the end it returns a long, but that's actually an address. And of course that's not going to work on 64-bit because a long is 32 bits wide, so they changed it to set window long PTR. They changed the argument type to a long underscore PTR. So if you're using the one at the top, you now have to use the one at the bottom. You've seen this before, without the ampersand in Visual Basic. It's one of those magic pointer types. It changes its size depending on the platform. But something to bear in mind during your migration. Okay. Word of warning, it's not limited. These changes are not limited to declare statements. It can occur in COM objects as well. Case 34 has an example. I was using a property called record count on a record set. I was using a long on that, and when I ported the example to 64-bit, it said, well, I can't do it. Check, the type is incorrect. So I had to change that again. You see the word long pointer here, and as you start to look that up, this is probably barely readable, but on this side there's the 64-bit version of the ADL library, the type library, and here it's declared as a long. Sorry, the 32-bit is the long, and the 64-bit is going to integer 64, which is the correct size. So even there, Microsoft had to go in and make the changes. Or actually, this is how the long pointer adapts itself to the platform. So it's always worth looking up which type library you are referencing if it's the correct one. Okay. Yeah, and a word of warning here, you have to get those sizes correct. If you don't, chances are everything will crash. Completely unexpected, unpredictable, depending on what goes wrong. So to try to explain that in graphically. The green pointer here, the 64-bit pointer, takes 8 bytes here and the 1 byte here, and that points to a correct address. But if you make a mistake in your pointer sizes and there is an offset, say, of 4 bytes, and you want the address, and you end up with these 8 bytes, you can see the top ones are 0. Well, basically, you're actually pointing back into the 4 gigabyte at the bottom, the 32-bit address space, which is probably not the byte you were looking for. So you have to make sure you have all the pointers correctly for all your arguments and all your return types, because otherwise you'll have to pay the price. Another example here is you can overwrite data. So your application is still reserving 4 bytes for an address or a pointer, and just above that there is some useful data here. And if someone actually gives you back a 64-bit pointer, your data is gone. So this is the data was living is gone, overwritten. So, and it's usually hard to find those things. Actually, I run into this myself recently. I was using a type library on top of a Windows, on top of a COM library, and I was using a function. I didn't realize that the returning pointer was still declared as a long, because I was using the wrong type library. So I was going through my code and stepping through it, and a for loop would never end. Because what happened was that this function was returning 64-bit pointer, which was silently overwriting my number. So every time it would reset the counter, and my loop would never end. So I didn't realize it initially, but this is how these errors slip in. So you have to be very careful in what you use. So what should have happened is that they had changed the type to a long PTR on my side, so I can just use it as is. So I can use a pointer. It doesn't really matter where I run my macro now. One thing to note here, on methods, sorry. This declare student shouldn't be here, sorry. But on regular methods, on 64-bit, you don't need the pointer safe. So it's not fully consistent in that respect. Okay, so we have to think again about this whole compatibility statement we've made earlier. So yes, your macros created in 2012 or earlier are compatible, but you have to make some changes. So you have to accommodate for these pointer types if you use them. The other way around, if you wrote your macro in 2013 and you want to go back, again, you have to change things for the pointers, but also if you use something which is specific to Visual Basic 7, like the PTR safe keyword or the long integer. So there is work to be done. how do you do this? How do you write version-specific code? You have to use this VBA concept, which has always been there, but probably not used that often. It's called conditional compilation constants. And so it basically allows you to say, okay, if this is true, then use this piece of code. If not, use that piece of code. So behind the scenes, there is a two-step process. This is your code now with these compilation constants in it. There is like a preprocessor running that leaves the line you want, and the compiler will then translate it into binary code. So this is the mechanism. It's very common in the C++ world. It's not as common in the VBA world. There was no real need for it. How do you do that? You can define them in code, or you can create them in tools properties, or they are predefined by VBA. And that's what the next slide is all about. There are two new constants in VBA to help you with this migration. One of them, of course, is very obvious. It tells you I'm VBA 7, which doesn't exist, of course, in VBA 6. So if you use that, your code will only be used on VBA 7, but not on VBA 6, because that statement that will be evaluate to false. So that's a massive help. The other one, of course, is also obvious. It's telling you whether it's running a 64-bit. Again, it wasn't defined in VBA 6. There was no 32-bit at that point in time, so that statement will evaluate to false silently. There's nothing to worry about, so that helps you as well. The one thing to bear in mind here is it will tell you whether the VBA code is running as a 32-bit or 64-bit. It doesn't tell you whether the platform, the machine, is a 64-bit machine. It will only tell you whether VBA is running a 64-bit. Which for SolidWorks, it's a one-to-one relation, because we no longer allow you to install 32-bit SolidWorks on 64-bit. We've stopped doing that. But for Microsoft Office, that's different. Well, you can run both flavors of Office on a 64-bit machine. So just something to bear in mind. For us, it doesn't really matter for SolidWorks. And of course, it always has been there. I think they've introduced Win16 and Win32 in the past, when the migration from 16-bit to 32-bit was happening. VBA 6 does define VBA 6. And that's something I struggled with, is that if VBA 7 is true, then VBA 6 must be true as well. So be careful. So what does a declare statement look like these days? You have to enclose it in these if-then statements. So if VBA 7, then we're going to use this guy. Otherwise, we're going to use this guy here. So it's a lot of code all of a sudden. Becomes even worse. So this is just for the function I'm going to use, the subroutine. But I have to make sure any data, any variables I'm going to use are also adapting themselves correctly to the size. So this gets messy very quickly. What I've done for the examples, just as an example, is okay, to avoid this endless enclosing, I thought, when I have to use pointers, I can basically define my own type. And that type has only one member. And that member, the type of the member is going to change. So if I'm on VBA 7, it's going to be a long PTR. If I am still on 32-bit, VBA 6 remains a long. So if you now look at your code, it looks slightly better, right? I still need it for my declares, etc. But my data here, I only have to make this change once. There are no if, defs, then around this anymore. And I just pass that one member back and forth. So just to clean up the code a bit, because yeah, it becomes very, very messy and hard to read if your code is cluttered with these if-thens everywhere. So, okay. I'm going to look at some case studies. I'm looking at the time, I think I have 4, maybe we can get into 2. Look, this one is just text without code. And I'll look at the other one using the ActiveX data objects later. So The other two are probably self-explanatory. Okay, so let's revisit this solution and have another look at this. Why did we do it the way we did it? In SolidWorks, there's then quite a few places where we return real pointers, so not COM objects, but real pointers, and we adorn them with these x64 postfixes. So this is just a warning sign, like, okay, careful. This returns something. This is a pointer, returning a pointer, which will change size on the platform. And in most cases, VBA programmers only use a method called getHWin to get the window handle for the main SolidWorks window. The other functions, which are 64-bit specific, are more for C++ applications. But this guy you're probably going to use quite often. So on our side, in the C language or C++ language, we use a 32-bit long capital L, lowercase l. I can't see it from here. Yeah, that's a lowercase l is C, which translates to uppercase long here on VBA6 or on VBA7 to LPTR. So that works fine. On 64-bit, we use a long, fully capitalized in C. That guy is not supported on 32-bit, which is very similar to what we've seen with long in VBA. And on the 64-bit side, again, it translates nicely in long PTR. So we cater for both flavors. You can use that. So code that would be using this could look like this. This is the long version. This is the shorter version using that data type for pointer I introduced earlier. So it looks a bit better, but still we need to make sure we're on the right platform. Because there is a catch here. If you look at this closely, do you see the catch? Do you see the mistake? The problem? No? Inconsistency? No? It's this line here. If you've used this, think about our intermediate solution. What we were actually doing is we were running your VBA code in a 32-bit process. And we were asking SolidWorks for the main window handle. But SolidWorks was 64-bit. So technically, shouldn't that be a 64-bit pointer for that window handle? And the answer is yes, it should have. And this is yet the tricky bit. Why did this solution actually work? The thing is not obvious that these window handles are not true pointers. They're not pointing to something in address space. They're actually just a number, just an opaque index saying, given this index, do something with this window. It's not living in space somewhere. And the trick here is that these numbers, these indices, all fit in 32-bit. So we don't need the other 32-bit. So basically what we call in programming, we truncate it. We say, let's get rid of the top 32-bit, and we just left with the proper value. And that's why it still works. So we're asking us a 64-bit application for something which is internally a 64-bit number. We truncate it and then give the lower 32-bit back to your macro. And that's why this solution actually worked. It's very tricky, and it's what we call pointer magic, right? Harry Potter. You have to put a spell on this to make this work, and you have to know what you're doing. So this truncation was safe to do. But again, be careful, because in the Windows 32 API, there are lots of functions which will give you back a handle, but it's a special value. It's the invalid handle value or a pseudo handle for a process. These special values are coded up as -1, not 0, which means address unknown. No, they use -1. So if you look at the number -1, the bit pattern for that is all ones. And the fact that it is negative is actually determined by the one here, the most significant bit. So if you start to lose that due to truncation, then you can no longer tell the difference on the 32-bit side here between this 64-bit number and this 64-bit number. So what you're left with is all ones in both cases. It just can't, forgot about these two zeros. So on the 32-bit, everything will start to look again like an invalid handle or a pseudo handle -1. So you have to be very careful here. On the 64-bit platform, always pass handles around with 64-bit data types. Otherwise, you lose data and you start to, your if test for these invalid things start to fail all of a sudden. So be very careful. Yeah, so actually what I did in my examples, I just basically said, okay, I've invented a data type for pointers. I'm going to invent a data type for handles just to remind myself this is a handle, not a pointer. And I just realized that actually I used the word address again, and I just told you it's actually not an address. So if you have a better name for this, please let me know. So one of the examples here is that the get current process API will give you back a pseudo handle. So I stick that into this data type of my own, just to remind myself. Okay. Let's look at this guy here. How many people of you are using Microsoft Access databases in there? Yeah, there's one. Anyone else? Two? Okay. Yeah, this is a case we came across actually 2 times now, that people were using that have been using it for a long time, and when migrating to 64-bit, they could no longer use it. And I will try to explain what the problem was and what the solution will look like. They were using OLE, DB, and ADO, and that combination started to fail. And we had to come up with a trick to make that work again, and I'll explain how. Going back to Microsoft Office 2007, the Jet engine, which has been the engine behind Microsoft Access for many, many years, had been replaced by Microsoft with something called the Access Database Engine, ACE. And if you think in terms of connection string, this is the provider name you have to use, right? So Office 2007, new provider, okay, no problem, you can download that, no problem. But of course, that doesn't come with a 64-bit version for that particular provider. And a provider, again, is nothing other than a DLL. It's the code that Microsoft uses to get into the database, so it must live in a DLL. So this is why it affects us, VBA developers. Of course, now these days, there is a 64-bit version for this provider coming with Access 2010. You can download that, but there is a catch. Say, if you've already installed Office 2010 32-bit, it doesn't allow you to install that provider alongside of it. So even the two should be independent, you think, but they're not. Microsoft doesn't allow it. And with 32-bit Office being the most common one still today, you're in trouble. Because the reason why 32-bit Office is probably most common is that a lot of add-ins that have been written for it over time are still 32-bit. So your IT guys will tell you, well, you can't have your 64-bit Office. So there was a problem here. So if you look at your connection string, which could still look like this, it will simply say, can't do it. I can't find this provider, I don't have it. So you're stuck. So how are we going about solving this? So we have to go back a few slides. You have to think again about our intermediate solution for 64-bit before we had VBA 7. Remember, we introduced a separate process which was able to host Visual Basic 6. We would communicate with COM, with SolidWorks, and it could still use your DLL. So this setup, we can actually do something very similar to solve this particular problem. Again, that property of COM called location independence will come to our aid. It will help us to fix this. And the way we've done it is we're going to introduce a very, very small COM object. I will show you the C++ code. It's very, very small. It's very, very simple. But it's very, very powerful. I'm going to host that, serve it from a 32-bit process. Very similar to what we did before, make a 32-bit process, and the only thing this object is going to do is create this connection, this ADO-DB connection for me. That's the only thing it does. And that's why we call it the factory object in our world. The only thing that is a factory, just give me a new object. And it returns that connection object back to your macro, which from there on can be completely left as is. That's the good news. There's nothing else we need to do. Then the 32-bit server with that will actually then create the connection for you, and it will then use all the ADO libraries and your new ACE provider, or the ACE provider. So what will happen then is that all the ADO calls will actually be executed in the 32-bit server process. And your macro, again, is completely unaware of that. Okay. So, and COM sits in between. So let's see what that looks like. Oh, of course, no. There's one other important thing here. I've written a small COM object, a custom object, but I let it live in a DLL, not in an executable. That's what I said before, right? It's going to be a 32-bit COM server and executable. But actually, I'm going to make it up of two parts. I'm going to write this custom object, and I'm going to give it a very special value in the registry, giving it an app ID, which will basically tell the COM runtime, okay, if this object is requested, I'm going to fire up this DLL host process, which comes with every Windows installation. I will fire that up for you and load your DLL into that process. And all I did was mark it up with this app ID. So that's the trick here. I've written it in C++, but any language you can use to write this COM object will do. Because as long as it's pure COM, it can be done. The only trick is to mark it with an app ID. So graphically, SolidWorks 64-bit with VBA7 living inside of it, it will request this factory object which lives in my own DLL. COM then fires up the DLL host for me, loads the DLL, and then from there on I'm just creating the connection object. I use that factory to create the connection for me, and then that's being passed back to my macro, and technically the factory can step out of the loop. It's no longer needed. It has done its job. From there on, it's as before. And then, from there on, it will use the 32-bit provider to access the MS Access database. Okay, let's see if we can do this live. So, we have SolidWorks. I'm going to load up my macro. I'm going to step through that. Okay. So first of all, I create my SQL query. I set my connection object to 0. And there is this, can you see it? The if-then compilation constant, right? I do something special now for VBA7, and actually I can do the same thing for VBA6, as I will show later. So in this case, I'm going to create, and I've called my special object called remote object factory, remote factory. So it's a nice name for it. So I'm using the standard create object, as we are familiar with, create the object. And now if we go to a tool called Process Explorer, I expand this for you. So we have SolidWorks running here. It will tell me all the DLLs that were loaded. But if we look up here, there is that host process I told you about. And that guy, if we inspect the DLLs that are loaded in there, you see this has loaded my remote factory DLL. That's the DLL I wrote. So that's COM has kept its promise. And if we now continue in our macro, so I have the factory in hand, and I'm basically going to ask it, and I've given it a very useful name, said create object. And what should it create for me? It should create an ADO connection. So I'm going to use this, which is, if you've used create object before for this, exactly the same. So what will now happen is that it will create that object in the server process. So we step through this line. You see what happened? There was a bit of green activity here. This is the ADO library, and it's loaded into the DLL host process, not in SolidWorks. So if we look at on the right-hand side, that is a 32-bit process. So things are looking good. Right? We're in the 32-bit world, not in the 64-bit world. So we can actually use that. So, okay, here's my connection string. And I'm going to open this connection. The reason I'm going to open it now, initially I only gave the customer, it was actually a partner, I gave the solution for the connection. But he came back to me and said, I actually need a cursor to go to my MDB database, which is updatable. And then it doesn't work with your connection object. So we found a solution and said, okay, why, if we do the same thing with this factory for the record set, that has to be updatable. So we can reuse that factory just to create another type of object. So that's why I have to open it now. And then I'm going to create my record set next. And that is also created in the server process. I no longer need the server process from here on. It will not close for now, just because VBA still has a reference to it. So ideally it could disappear. Oh no, sorry, that's nonsense. Ignore that. So now I have my record set in hand. I just query for the cursor type. Let's step into that. It says, if you can't read it, it's forward only. So it means it's not updatable. Not yet. But at least now I can make it so. So I open the connection. Open the connection on this record set. Execute the SQL query. And if I now look at the cursor type, it should tell me open key set, which in ADO terminology means it's updatable, which is exactly what I wanted. So by now I have two objects living in my server process, working nicely together, because they live in the same process. So ADO is happy. So I can do updates. So I let this run. Poof, there we are. I just run it again. So if you look at the bottom here, there will be a new record I've added myself. So look, we're looking at that again. So I was able to add this record here myself. And the only thing we needed to do was to make sure we got hold of this factory object instead of doing a create object on the ADO-DB connection. I've used my factory object to use the create object. Is any of you familiar with C++? No? Okay, but I won't go into much detail then, but yeah, the only interface I needed to create was the create object interface, which takes the class ID of the object I want to create and then comes back with the object. So this solution can be used for other objects as well. Of course, no guarantees if the object really works, but this is a way to do it. And if we go back to the PowerPoint, this will actually work on 64-bit for 2012 as well. So schematically, this is what you have, right? Your VBA6 in its own process would communicate directly with the ADO, DLL. Well, actually, it doesn't hurt to just use the same solution. Because it's such a small object, it's such a small DLL. So basically, you can use the same code on both platforms if you have to support both. So instead of using only this, you can use both. Question?
The DLL has to be time registered, correct?
Yes, yeah, that's, yeah. My Visual Studio does that for. Yeah, that's the downside. Yeah. It has to, COM has to know what to look for and where to look for it. That's, yeah. Okay. So for SolidWorks 2012, I could show the exact same image. Oh, sorry. But of course, the one thing to note here is this: now the server, the DLL can be loaded into the Visual Basic process. So COM will say, okay, well, this host is requesting this object, the factory object, but it's 32-bit, so I'm perfectly fine to load that 32-bit DLL into that process. So we're not going to use that surrogate host. So that's fine. And actually, if you look at it, at 32-bit, you can use the same thing, because that's all 32-bit. So COM will say, okay, fine, I can load your factory object in that process as well, no problem. And again, if you spotted it, 2012, we can do the same thing. So given that it's such a small DLL, maybe it's worth to use it in all your supported versions, platforms, and be done with it. Okay, I already got the 5-minute sign, so I think it's 12 o'clock, we have to stop. The other two cases I had in mind, let's quickly run through them. Yeah, number 2. Here the problem was we don't have the active control to look for a file, and here the solution was just go one level below it and use the get open file name API that's available, configure that, and I've written a small example right here, my own little object in VBA, which has the exact same interface as we used to say this is the starting path, this is the filter, now go look for it. And so changes are very small. The only problem here is that, as you've seen, VBA warns you 3 times if it can't find an object. And there is no way we can use the conditional compilation constants to get rid of those warnings. It works for code, but not for controls on a form. So here you have to basically say copy your entire macro, make the changes, and then have to use 2 different macros. So that's a pain. The other case is quite similar. This is the function you used before to give a pointer, give me the path it's actually pointing to. That uses a pointer. It uses a complex data type called browse info, which has members which are pointers, so you have to get those correctly. One of those members is a function pointer, so it's pointing to a callback, a VBA callback. So it demonstrates how to get hold of a function address on both platforms. And to make it even more complicated, one of the callback data is actually the COM object itself that does the browsing. So it's a lot of ways to illustrate how to work with these pointers in the Win32 API. Everything will be available to you for download. If you can't get hold of it through the conference organization, just give API support at SolidWorks a bell or an email, or just get my business card. So we'll get it out to you. Question?
So aside from COM references, is an MDB built on a 64-bit computer compatible with the 32? Like, users can just quick play and run it? Or
which was that, sorry?
If you build a MDB or a macro file on a 64-bit computer, or 64-bit SolidWorks, and bring it to a 32-bit version of SolidWorks, will it just run, or does it have to be open?
But what I've seen, most of the time I can just open it, and run it. Sorry, I'm used to open the files view because I want to look at it. So, but it doesn't tell me to recompile it. If it's happy with the type libraries, if you can find your type libraries, then it will probably run straight out of the box.
Okay.
Yeah. Any other questions? No? You've been dazzled and tired and in need of coffee. Okay, no problem. Questions will always come later. Thanks for coming. Bye-bye.